State the intercepts and asymptotes of a rational function. Sketch the graph including intercepts, asymptotes, and general shape of the curve. So let's factor this rational function. The numerator is x minus 5. The denominator is x minus 4 times x plus 1. Okay, so intercepts. If we plug in 0 for x, I think the original form is easiest to do. 0 for x, we just get negative 5 over negative 4. So 5/4. And then if I let x equal 5 in the numerator of this function, I can get 0 over non-zero, that's 0. So here we have the y-intercept and the x-intercept. The asymptotes. Back to the original, we can see that this rational function has the degree larger in the denominator. That gives us the horizontal asymptote of y equals 0. So y equals 0 is the horizontal asymptote. For the vertical asymptote, we look at the denominator and we see x equal negative 1 and x equal 4 being the vertical asymptotes. So here we have the 2 intercepts and the 3 asymptotes. These were the items requested. Now we want to sketch the graph, including all of this information. So y equals 0 is the x-axis. X equals negative 1, we have a vertical. And x equals 4, a second vertical asymptote. We have 0, 5/4 is a y-intercept. And 5, 0 as an x-intercept. Now this x-intercept is interesting because it's sitting right on the horizontal asymptote. Now the horizontal asymptote is the end behavior, so it doesn't really impact what happens in the middle of the graph. The only part of this graph I really can surely graph is this piece in between the vertical asymptotes. So the graph is always going to approach the asymptotes. Now the fact that it doesn't have an x-intercept before it gets to this next asymptote tells me that this thing's going to turn right back up and continue up. Now for the rest of this, you could use multiplicity. Specifically, the multiplicity of all of the x-intercepts and the vertical asymptotes are 1, which tells us that the sign, positive or negative sign, will be opposite on each side of these events. So for example, the negative 1 vertical asymptote, is odd multiplicity, which means on the right it's positive, on the left it'll be negative. So that would be enough to sketch the left side. At 4, we have odd multiplicity, so it'll change signs. On the left is positive, on the right it'll be negative. Now this one has an x-intercept. The x-intercept itself is odd multiplicity, so it'll be negative on the left, positive on the right. So it's crossing. But we have a horizontal asymptote, so this thing has to bend back down and approach that asymptote. As you're graphing these, make sure your lines are approaching asymptotes. I have graphs that look like this, which is not appropriate. I have graphs that kind of bend back down when I'm grading. That doesn't work. I have graphs that just don't quite approach the right line. So make sure yours are approaching the correct asymptotes. Now the other way besides multiplicity would just be to plot some extra points. For example, what happens at negative 2? We would have negative 7 over negative 6 times negative 1 is 6. We have negative 7, 6. So it's really right there, but it's still enough for us to know that it's below, and we're just trying to show the general shape. So this is still okay. And then if we plug in positive 6, and we would get 6 minus 5 is 1. 6 minus 4 is 2, 6 plus 1 is 7, 2 and 7 is 14. Positive 6, it's really not very far up off the X horizontal asymptote, but it's still above, which we have the general shape mimicking. So hopefully this helps you get quick sketches of these types of graphs.